Hi, we're Team 5 in Electro-Mechanical System Design. Welcome to our COVID killer sanitization system project.
But what do you hate the most about shopping during COVID?
Well, I need to sanitize all my items after I go home. This virus can live on the package of retail goods, so I need to sanitize all my items using alcohol spray. It will be really helpful if there is a machine to sanitize all my items for me.
2,000 years later.
If we are designing a sanitization system for the supermarket, what location would you prefer it to be installed?
I would prefer it near the exit of the supermarket.
What are some features you would like to see in the sanitization system?
Well, I would like it to sanitize my items in 5 minutes because I don't want a long line at the exit of the supermarket. And also, I don't want any chemicals or odor after sanitization.
Our team has also interviewed shop employees who want the system to be under $1,000 and easy to refill.
We identified 3 primary questions for the implementation of the proposed device. They can be summarized as when, where, and how. When would the sanitization occur? Before, during, or after the checkout process? Where would the device be located to ensure it was easy to use without disturbing the natural traffic of the retail environment? And how would the method of sanitization provide effective and continued value? A wide array of concept combinations were explored and evaluated. Ideas ranged from continuous in-cart disinfectant devices to large-scale push-through conveyor systems that could sanitize an entire cart in one pass. Eventually, several combinations of screening and scoring matrices were used to down-select to our final implementation.
As the drawer opens, the user can put in a special design basket full of items into the drawer. After the drawer closes, an elevator will lift up the basket to drop all items into the drawer. The empty basket will then be returned to the user from the back of the box. Finally, UVC light is going to sanitize the items and they will be returned to the user. The process can be monitored on the touchscreen in front of the users.
Detailed analysis of the UV lighting system was required to determine best arrangement of lighting elements within the system. We devised a testing procedure using a UV sensor to systematically measure the power output of each UV bulb. With this information, the complete system solid model was loaded into ANSYS Speos for optical analysis. Ray tracing simulations were conducted for a large variety of lighting configurations, replicating the transmittance of UV light into a dense, unstructured grid of generic retail items. Incident power values were recorded for all item surfaces. This testing accelerated the selection of final bulb placement and verified the expected UV sanitization performance that is required for the effective usage of this device.
We used ultrasonic sensors to test the performance of our elevator system, and we found out that our system is mostly balanced after we have changed our step motors to motors with larger torque. Our elevator system is now working smoothly. To make sure our system is safe for fragile items, we conducted drop tests in which we dropped items from different heights into the drawer to see if they remain intact. And our results show that our system is safe for fragile items as long as the dropping height is less than 14 inches.
So in our speech recognition test, we aim to test the speech recognition performance under ambient noise. So we delay a couple of seconds to obtain ambient noise pattern and trim out that noise. We see the relationship between the ambient noise level, delay times, the performance, and the action word picks. CMU Sphinx can successfully recognize sample voice commands under 45 to 65 decibel ambient noise with only 1 second delay for noise trimming. Time of the ambient noise pattern does not actually affect much to the results. We just need to avoid using words with voiceless consonants such as S and TS commands. The speech recognition with noise trimming under 75 decibel ambient noise is not so satisfying, but we certainly found an alternative solution to look for arbitrary words and define the dictionary to complete those sentence message under each noise level.
Based on our sanitization analysis and surface coverage test, we added more UV lights to our system. Also, we added 6 bearings, 3 on each elevator beam to reduce the displacement based on our FEA. We have also improved the elevator performance by changing to higher torque stepper motors. Finally, based on physical prototype testing, we redesigned the rack and gears and used a gearbox to optimize basket returning beam performance. This project has demonstrated the entirety of the product development lifecycle in an accelerated format. In sum, we have applied practical research, conceptualization, design analysis, and testing to produce an electromechanical device with the potential for real-life value in these difficult times. Thank you for watching our video demonstration.